I'm about to share an example that never fails to evoke amazement among my students. Almost each time, I can literally hear them awed and surprised or ready for a debate. I hope I can create the same amazement in you. You will have to wait though, because I like to give some revision of Newton's third law, which I feel important. It is part of the 3 video series, one for each Newton's law of motion. In this video, we will focus on Newton's third law. Please watch all of them as we bring interesting aspects. Let us begin. These are the typical examples you are familiar with. Let's revise. The first example is the rocket ejecting the fuel downward with a powerful force. The rocket's action is met with equal and opposite reaction by moving upward. The Newton's third law always involves two objects. In the second example, even the simple act of walking has a fascinating interplay of action and reaction. As you walk, the earth reacts by moving slightly backward. But because the earth is so massive, you hardly feel the effect. If you are not convinced, let's replace the earth with a lighter mass. Say a boat shown in the example 3. When a person takes action by jumping forward, the reaction is boat moves downward and backwards. Why downward and backward? Because the person jumps upward and forward, so the reaction is equal and opposite. The fourth example is firing a bullet from the gun. The bullet's action is met by gun's recoil as a reaction. Now let us focus on impossible example. Some of it is outright funny. Example 5 shows a person in the truck pushing the truck. Do you think he's helping the truck move? Not quite. Just like the previous boat example, he is pushing the truck backwards by his leg, but by his hand he is pushing the truck forward with equal force. The result is he is making no impact. The sixth example is a toy car that is pulled by the magnet. The only problem is magnet is connected to the car. Do you think he can create a perpetual motion and propel the car? Again, not quite. The magnet will provide the force forward to the car, but the handle that is connected to the car and magnet will push the car backwards with an equal force. The result is no action. Now let me show you some intriguing examples. This is a clip from a popular Phantom comics of the 1970s. Let me ask you a question. Why do you think perching a person's face is going to hurt him? After all, according to Newton's third law, the face will provide an equal and opposite reaction. The answer is the bones in the hand are far more stronger than bones in the face. So although the force felt by both is same, the same force is more damaging to the person who is hit. If you are not convinced, let us reverse the role in the example 8. Let the person punch a wall. The wall will exert the same force in equal and opposite direction. Yet, since the bones are far more fragile compared to the wall, the person who punch will get hurt. Still not convinced? You can try to punch the wall. The harder you punch the wall, the more easily you'll be convinced. I hope by now you had a good revision of Newton's third law. Now let me come to the final star example, which everyone find so amazing. We have two blocks of mass m1 and m2 tied with a massless and stretchless string. The block of mass m2 is being pulled by a force. We are asked to find the tension T1 and T2 acting on a string as shown in the figure. At the onset, the problem looks very complex. But let us imagine that we cover the whole system in a big virtual box, which has no mass of its own. Now the problem looks very simple. One block being pulled by a force F. Anyone can easily calculate the acceleration of the block, which is F divided by m, where the mass m is actually m1 plus m2. Why? Because they are the mass of the blocks inside. Now let us remove the big imaginary box, and we have important information that each mass m1 and m2 are accelerating with the same acceleration F divided by m1 plus m2. Proceeding further, let us focus on mass m1 as shown in the dash red rectangle. We know the acceleration, we know the force T1 pulling on mass m1. So we get T1 is equal to m1 times acceleration, which is m1 times F divided by m1 plus m2. Now let us focus on the mass m2 as shown in the dashed red rectangle. The net force acting on m2 is F minus T2. Since this is unbalanced, it should be equal to m2 times acceleration according to Newton's second law. Substituting acceleration, we get the terms that can be reduced to this. And lo and behold, we get the tension same as T1. So we have equal and opposite force, and this is due to Newton's third law. After watching this slide, do the math yourself, and you will find the joy of finding this out. I do hope that you also find the example awesome. I hope you found the example really awesome. Now you can also do the extended example shown below and prove that T1 equals to T2 and T3 equals to T4. Thank you for watching the video and bye bye.